So here we will talk about how to find the length of the curve for parametric curves. The parametric curves are of this form: x is equal to f of t and y is equal to g of t kind, where t is defined in some closed interval, say alpha to beta. Moreover, this quantity f dash t should not be equal to 0. Why? Because when you calculate dy by dx, that quantity would be simply be g dash t divided by f dash t. So this term should not be equal to 0 for this to exist, right? So the rectification of parametric curves, that means you can find the length of the curve in for the parametric curves using this relation. So you will perform the integration from alpha to beta, whatever interval that is given to you, and then you will take the square root of the first derivative of x with respect to t, the first derivative of y with respect to t whole square, and then you can perform the square root. Simple as that. So the question here is, we are to find.
मैम आवाज कट रही है मैम.
So here the question is, find the length of the curve, find the length of the curve. The curve, parametric curve that is given to us is x is equal to t cube and y is equal to 2t square, and t lies between the interval 0 to 1. So here we are to find what is the length of this curve. So here, what is the formula? The formula is, we have to take the integration from alpha to beta of this quantity dx by dt whole square plus dy by dt whole square root, and integration is to be performed with respect to the parameter t. So for that we will first calculate what is dx by dt. So we have x is equal to t cube, so dx by dt, that would be 3t square, and we have y as 2t square, so dy by dt, that would be equal to 4t. So this is known to us. So this would be integration from, what is alpha, what is beta? Alpha is 0, so we will perform the integration from 0 to 1 of the quantity square root of this quantity, so 3t square, and then the square root of this quantity, square of this quantity, so the square of this and the square of this 4t dt. So see, let us see what do we have. So it would be 9t to the power 4 plus 16t square, right? So 9t to the power 4 plus 16t square into dt. So we can simplify this a bit, integration from 0 to 1. Then you can take, what can you take common from here? So you can divide by this quantity 3t square. So when you divide by 3t square, or you can take this 3t square common, or in fact 9t square common, so it would be t square plus 16 divided by 9. So this is the quantity that we have. So now we can take this out from this square root, so it would be integration from 0 to 1 3t, and within square root we have t square plus 16 divided by 9 dt. So how can you perform its integration? You can substitute this quantity as some other variable, so t square plus 16 by 9, you can put it as, say, a, right? So what would be its derivative? It would be 2t dt, that would be dA. So whenever, and your limits would change from, whenever your t is 0, what is a? A is 16 by 9, and whenever your t is 1, what is a? A would be 1 plus 16 by 9, so that would be 25 by 9. So this quantity would become integration from 0 to 1, then 3t, instead of t we have this t dt, it becomes t dt, it becomes dA by dA divided by 2, and this quantity square root of t square by 16, it becomes square root a, and limits now change from 16 by 9 to 25 by 9. So you can solve this integration, and the final answer would be, so here it would be a to the power 3 by 2 divided by 3 by 2, and 1 by 2 is outside, and you can substitute the limit 16 upon 9 to 25 upon 9. So the final answer is 61 divided by 27. So that is the length of this particular curve, parametric curve. So I have one question for you, please note it down. So the question is, the position of particle at time t is given by x is equal to 1 by 3, 2t plus 3 raised to power 3 by 2, and y is equal to 1 by 2 t square plus t. Then find the distance moved by the particle between the points t is equal to 0 to t is equal to 3. So this you have to find out, what is the distance moved by this particle. The answer to it is 21. The answer to it is 21 divided by 2. So that is it for this class.